Today's lesson is on section 3.4 or module 3, lesson 4, solving quadratics by factoring. All right, and so first we got to really understand some concepts of factoring and base values of it. Before we get into factoring, though, we have to understand the zero product property. And there's really two parts of this you need to understand. One is that you have to set it equal to 0 to start. Right, to factor it, to start this problem, remember that we're finding the roots of the solutions or the zeros. So roots, solutions, and zeros are three things that mean the same thing for us here in this unit. And so it must be equal to 0 in order to factor it. And then once you do have it factored, you're going to set each part equal to 0. And so if you have like x plus 3 and x minus 2, equals 0. So that's already factored. We'll talk about factoring more, but that's already called factored form. You would set each part individually equal to 0. And so in this case, you would get minus 3 to both sides, negative 3, and add 2 to both sides, positive 2. And so that is the zero product property. That is how you use setting it equal to 0 to help you find the solutions after you factor. And so this is just a review of factoring by what's called greatest common factor. All right, 3 goes into both 3x and goes into 9. So 3 times x makes 3x, and 3 times 3 makes 9. So you're pulling the 3 out, and that is the greatest common factor. And so let's look at that here in this example. And so we have 4x squared minus 8x equals 0. Well, it's already set equal to 0. We love that. So what goes into both of the terms? What goes into 4x squared and 8x? Well, 4 goes into both of those numbers, and x goes into both of the variables. X the first goes into both. X the second goes into the one on the left, not the one on the right. And so 4x times x makes 4x squared. And 4x times negative 2 makes negative 8x. Another way you can think about this is once you decide what the greatest common factor is, you can do it's like you're dividing both parts by that greatest common factor to figure out what goes inside the parentheses here. Okay. So that is, this whole thing here is factored form. So to solve it, to get the zeros or solutions or roots, I have to now set each of these parts equal to 0. So 4x equals 0, x minus 2 equals 0. Anytime you don't have a plus or minus, it's just going to be x equals 0. Here we're going to add 2 to both sides, and so we get x equals 2. So those are my two solutions or roots to this problem. On this one, we need to first subtract x to both sides. And so I get 12x squared minus 3x equals 0. And so what is the greatest common factor? What goes into both 12x squared and 3x? 3 does, and x does. And so again, I think of 3x times what makes 12x squared. 3 times 4 makes 12. X times x makes x squared. And 3x times 1 makes 3x. Or you could think of it as dividing both by the greatest common factor. Once you do have it factored, again, you set each part equal to 0. And so on the left-hand side here, you get x equals 0. Over here, you would first add 1 and then divide by 4. And so you get x equals 1/4. And this is the first instance where I would say, this is an instance where factoring is better than graphing because it's really hard to tell a fourth on a graph. And the more of a decimal, the more rounding that's involved. Rounding is bad in math. Rounding is bad in advanced math. And so that's why we learn other methods besides just graphing and using the tools. Factoring and trinomial, hopefully this is review from your Algebra 1 class. You have to tell yourself or ask yourself what numbers multiply to make that last number, that end number, but add up or or combine to make the middle number. And so for this one, we're looking here. What numbers multiply to make 15? Well, because it is plus 15, I know they're going to be the same, meaning they're both going to be positive or both going to be negative. Because this is plus and this is minus, I know they're both going to be negative. So negative 1 times negative 15 or negative 3 times negative 5 make 15. Well, when I add them up, these do not add up to negative 8. These do add up to negative 8. So winner, winner, chicken dinner. I plug those in, and this is the factored form of my trinomial. And so let's look at that here. What numbers multiply? Multiply to make 6. And so multiply to make 6 would be 1 times 6 or 2 times 3. I want them to add up to make 5. 1 plus 6 makes 7. 2 plus 3 makes 5. And so my factor form here would be x plus 2, x plus 3 still equals 0. Again, now that I have it factored, I set each part equal to 0. And I get my two answers, negative 2 and negative 3, after I solve them both. First step is that you have to have it equal to 0. So I'm going to have to adjust this equation to x squared minus 6x minus 27 equals 0. And so now I'm asking myself, what numbers multiply to make negative 27? And there's lots of choices here. 1 times negative 27 or negative 1 times positive 27. Or 3 and 9. I can go negative 3 and positive 9 or positive 3 and negative 9. I want them to add up, all right? Add up to negative 6. And so that goes down here. This is the only one that adds up to negative 6. So that's our winner, winner, chicken dinner. And so x plus 3 and x minus 9. Because it's positive 3 and it's negative 9. And I set each part individually equal to 0 and then solve each part. And so I get negative 3 minus 3 to both sides. Add 9 to both sides, I get positive 9. So those are my solutions or roots to this equation. And that is the gist of it. There's a couple special rules here we need to be aware of. This one some people call perfect square. It's really called difference of squares. It's when both of the terms, so the first thing and the second thing, there's only two parts, and they're both perfect squares. So x squared is x times x, 49 is 7 times 7, and it has to be minus. It has to be a difference. Then I can break it up into two sets of parentheses. X and x makes x squared. 7 and 7 makes 49. 1 positive, 1 negative. That's called difference of squares. All right. Or perfect square trinomial. Perfect square trinomial is a little bit harder to recognize. A lot of kids will miss this one. That's fine. If you miss it and factor it out, you'll still end up with x plus 7 twice. But this is a perfect square. So x and x, this is a perfect square, 7 and 7, all right? And so it'd be 2 7x's, which make 2 times 7 makes 14. And so you can just do it as x plus 7 squared. Right? And we'll show you an example of both of these. Here, again, the first thing I need to do is get it equal to 0. So I want to have minus 81 to both sides, and I get it like this. Now that's the same as x squared minus 81 equals 0. You can rewrite it or not. That is up to you. All right. I get x plus 9 and x minus 9 because they're both perfect squares here. X squared is x times x. 81 is 9 times 9. All right. I set them both equal to 0. And I get negative 9 and positive 9 as my answers. Last but not least, First thing I have to do is set it equal to 0. So I already did all of that work for you here. And then 9x squared is a perfect square. It's 3x times 3x. 81 is a perfect square. It's 9 times 9. All right, you have to do 9 times 3 times 2 to get 54. This is a little bit tricky. But then you would set each one equal to 0. Well, it's the same thing twice. I minus 9 to both sides. I get 3x equals negative 9. I divide by 3. I get x equals negative 3. And so that's your answer. Now, it's really happening twice because of the squared. All right, so that's something we're going to get to later called multiplicity. It's negative 3 with a multiplicity of 2. But for right now, just know that negative 3 is the answer. This is the assignment I would like you to try tonight. I wish you the best of luck.